Good morning.
Morning, sir.
Morning, sir.
Good morning, sir.
Good morning. Okay. So in the previous session, we were started to come to know the classifications of groups. Okay. So in which cyclic group and particularly we are also discussed how. Sorry. Yes. So we had discussed also like to determine the order of the group, order of the element in a group. So in two different classifications also we are discussed. So in cyclic group, can anyone try to say the definition of cyclic group? Can anyone try to recall that? Four days ago it was started to discuss. Anyone? Cyclic group. Anyone, could you please say the answer quickly?
If we can get every element in the set by raising one of the elements to
Super. Very good.
a power, any
Okay.
integer power.
Very good. If suppose you may have the set of elements in which I can pick one common number A that belongs to G as well, that can rise by some power. Okay. But by some number. So if I get that number, that will be the cyclic group, or what is the definition? Yeah. This M is the order. Okay. But what is the original definition of cyclic group is you can pick. See, this is the definition. If you could read it, you can get the answer. See, you may have the numbers like 1 minus 1 I minus I, in which so you can pick one number. If you could rise by some common number, you will get back the same your members of G. Okay, so here the common number has taken A as I. So here if you could take I rise to the power 4, likewise power 2, so you can get back the original values of G. So in this way, if you are able to write, means that group is cyclic group. Always you will be getting confusion between cyclic group and then order of the element. See, order of the element is nothing but you can just the same number will be raised by some integer. That number will give the answer identity, in which M is the order. Can you get the difference between order of the element and then cyclic group?
Yes.
Okay, fine. Now we can move into this. Okay, so in this we need to solve one more problem in this group concept. See, for example, Z5 plus forms a group. We need to prove like Z5 comma plus. So here, if they didn't mention that plus yeah, under anything, means it is considered like addition modulo 5. So first you need to consider this as a congruence modulo. You need to expand that Z5 like 0, 1, 2, 3, 4. That's it. Okay. After this, you need to create a table, that is K-list table. So here plus 5 you need to apply, right? So 0, 1, 2, 3, 4. Likewise 0, 1, 2, 3, 4. After this, simply you can apply the addition modulo between them. Always if I apply 0, I will get the original values of the columns respectively. Because if I add with 0, certainly I can get the same answer. Next. So here also I will be getting the answers like 1, 2, 3, 4. After this, 1 plus 1 mod 5. What is the answer?
So 2.
Very good. Next.
3.
Very good. Next.
4.
Next.
And then 0.
Very good. Super. After this.
So 3.
Okay.
4.
Okay.
0.
Okay.
1.
Super. So here 2 plus 4 is 6. 6 mod 5 is 1 because the remainder for that value 1. So already I have explained that. So I don't want to waste the time to explain this. Yes, please.
Then that will become 3, 4,
Very
0,
good.
1.
Very good. Very good. Very good. So here 4. So that is 4. Next 0, 1, and then 7 will be 2, right? Next. So 0, 1, 2, and then last one is always the missing value will be the answer. You can just check in horizontally as well the vertically. There will be the some uniform will be there like 0, 1, 2, 3, 4. There will not be the repetition in each rows and then each columns 1, 2, 3, 4, 0. So here also 0, 1, 2, 3, 4, 0. Okay, likewise. Okay, you can just cross check whether you have done correctly or not. Even the professors will do the evaluation, will check like that only. If the students would have repeated on it, certainly the marks will be cut off. For that Cayley's table, it can be reduced. So always, genuinely you need to check once if you have done the apply the way, you need to cross check whether I have done correctly by applying to this kind of shortcuts. But always shortcuts should not be applied. So this is a shortcut to check whether you have attained the correct answers or not. Okay, after this, straight away you can just go with the axioms. Closure. Okay, so here between two elements, if you apply the addition modulo phi, whatever the answers you have got, that belongs to the set what it is provided Z phi. So from which whatever the operation, whatever the values you pick as a pair, if you could apply the addition modulo phi, it will compensate the values which exist in your Z phi. So from which closure axiom is true or not?
Yes, sir.
Yes, you need to mention here from the table closure axiom is true. Okay, next associative. Okay, next I'll raise one more question to you. So I can pick 3 elements. Like I can randomly pick just to show the example. 2 plus 3 plus 4. So here 2 plus 3 plus 4. So now you can say the left hand side answer first. Addition modulo, okay. So here 2 plus 3 plus 4, 7, mod 5, what is the answer? 2, right?
2.
So 2 plus 2, addition modulo 5.
4.
4, very good. So this is the left hand side answer. Can you just predict the right hand side answer?
4.
4. Certainly you will be getting the same answer. Okay, I hope you are understood. So I don't to insert this. So from this you can straight away mention in general from the table associative is axiom also true. Now identity axiom, since it is used addition, can you just guess what will be the addition identity element will be there?
0.
0. That's it. Very trivial. Okay, so 0 will be the identity element. Sorry, belongs to G. So sorry, not G, Z5 is the identity element. So it satisfies the rule. So you can mention like identity axiom is true. Okay, you need to write like that formally. Next, inverse. This step many persons will do the mistakes. So inverse axiom always it is used to say like, yes, so it can say like A star A inverse. Here star represents, according to this problem, addition modulo phi equal to E. Okay, so here E represents 0. So here for what value of Z phi, I can multiply with, I can apply the addition modulo phi with that number I should get the answer as 0. So will it be the unique number for all the values, or it can be distinct for with respect to the element?
Unique, sir.
It is unique. How? Okay,
It's
now I'll
different
write
for everything, sir.
Very good. You are reverted from your point, right? So here, see here, if you just check 0. So 0, for what value if I add 0, sorry, for what value to add with 0, I should get the answer as 0. Certainly 0. So I should stop at the value 0. Respective value will be the inverse element. So likewise, so you need to mention here. Inverse element of 0 is 0. Next, inverse element of 1 is, can anyone try to say?
4.
4, because see here, inverse element of 1 is for what value if I add with some number, I should get the answer as 0. So I can just plot at the respective value 0, the corresponding column value will be the inverse element. So inverse of 1 is 4. Next, inverse element of 2 is, sorry?
3.
3. Very good. Next, inverse element of 3.
2.
Inverse element of 4.
1.
1.
1.
1.
Okay. So that's it. So all the 4 axioms are true. Here you need to mention like inverse axiom is true. So from all the 4 axioms are true, I can close the topic like Z5, comma plus under 5 forms a group. So this is has been done by using the Cayley's table. That is, first you need to apply the Z5 expansion. After that, you need to proceed into the modulus congruence table. After that, you can check all the 4 axioms whether it is true or not. Okay. So I just need to raise one more question in addition to that. Is it a abelian group or not? Is it abelian group or not?
Yes, sir.
Yes, because commutative axiom is certainly true for this. Clear? Have you got it? Have you got it?
Yes, sir.
Yes, sir.
Okay, fine. See here, last definition, with that I'll close. So please listen. So here, next subsection of this model. So subgroups. So in your previous topic, you are started to know the semi-group, right? Semi-group. So group means it has to satisfy the 4 axioms. 4 axioms, that is group. Semi-group means partially, like exactly of first 2 axioms, if it is true means that is semi-group. Already I've told you, semi-group is exactly a different concept when you compare with the subgroup. Semi-group is not equal to subgroup. Semi is not equal to subgroup. Both are different, so don't get confused. Semi-group is means if it satisfies closure axiom and then associative axiom means, then I can call that non-empty set with respect to the operation is called semi-group. Okay, subgroup is different from the semi-group. Okay, yes, first we can enter into that. See here, subgroup means, yeah, they will be better. I can just write in the. Don't get into the definition. I'll just explain to you. See here, first you can consider there will be the group G. I'm going to consider one subset of the G. That means I'm going to take one subset from the G. For example, if you can take like 4, 5, 6, 7 and then 9, 10 means this will be G means I can take one subset like S as 5, 6, 7. So this will be my subset. After this subset is called a subgroup. When it can be called as a subgroup means it has to satisfy some conditions. What are all the conditions? First you need to understand. First condition, it has to be a closure. That means it has to be a closed. S is closed. That means it has to satisfy the closure axiom. First one is closure. Second one is listen carefully. This is different from the semi-group concept, so please listen. Second one is, so you need to choose. You will be there on. You will have one element E belongs to S. That E will be the original identity element of G. That means whatever the identity element of G certainly will represent in that particular set, subset, right? Whatever the identity element you have already taken in your G, that should be placed as well in your S also. That means subset also. Next, last condition. So likewise, there will be one element A inverse belongs to S means that A inverse, that means that A inverse already has been the inverse element of G. Can you get the point? So if it is so, then I can call this S is my subgroup. I'll repeat the concept again. So if non-empty subset of a G can be called as a subgroup when it satisfies three conditions. First condition, it has to be a closed. That means it has to satisfy the closure axiom. Next condition is if identity element E belongs to G means that same identity element should be there as a element in your S. Okay. Next, if A inverse can be the inverse element of G means that same inverse element should be there inside the element in the S. Okay. If it is so, then the given non-empty set with respect to the operation is called subgroup. Have you understood this definition? Have you got it?
So basically, it's the sum, like it's a part of the main group only, which satisfies the main the conditions of main group, and then this.
Yes, instead of showing the condition, just to satisfy the element can be placed into that subset. That's it. That's more than enough. Can you get that? But more or less, as you said, it can be satisfy the main group axioms. That's it. Not every, slightly, it can partially satisfy the axioms. Instead of satisfying the property, it can simply say that element can be placed into that. That's it. Obviously, that will satisfy, right? Can you get the point? Have you understood on this definition? Have you?
Yes, sir.
Okay, fine. Next. So 1 minute, I'll close it. So here, you can consider Z comma plus. Is it a group or not?
Sir.
It's a group. So it's a group. So now E comma plus. Can I say E comma plus? That means E is the subset of Z or not?
Yes, sir.
Okay. So now can I call this E as a subgroup or not?
No, sir.
Why?
So because inverses don't belong to E.
Why? See, what first you need to say, what is E? So E is nothing but even integers, right? Set of all even integers. So that time it can be like -4, -2, 0, 2, and then 4, 6, something like it can goes on like this. So now first I can check for the closure. So here, if you add any two numbers, certainly it will compensate the property of that closure property. So first one is closed is true. Next. So originally, what is the identity element of Z comma plus?
0.
0. So certainly 0 belongs to E only. So it is true. Also 0 belongs to Z. So it is true. Third one, inverse. Will it be true or not?
Inverse is not defined. Right? 0 and 1.
Inverse is not defined. Why?
Sir, inverse of the identity element.
No, I cannot get the point. What you are saying.
Sir, you told
It is
us that
divided.
It is inverse is satisfied or not?
Oh, sorry.
Yes, sir, it is satisfied.
Very good. It is satisfied. See, you can check any numbers. Okay, because if this set is not there means certainly, as one person said, like it is not true. It since it is included, so certainly this is also satisfied. Got it? Okay, fine. So is there any doubt on this subgroup concept? See, please go through the problems in the groups with the examples. Like you can refer the your schooling books, or you can refer the materials, because in this model you can expect the questions like only the check whether the non-empty set with respect to some operation it's a group or not, or abelian group or not. In that way only they can raise the questions. So you have to be ready